In this clip, I'm going to introduce the concept of eigenvalues and eigenvectors of a matrix. Suppose we have this square matrix A, which is as follows. And I'm going to multiply this matrix by a few column vectors. Here's the first one. Multiply it by -1, 1, 0. You know how to do this. Do the computation. We get this. And another example, the same matrix A, this time by column vector 1, 2, 3, and we get this. Here's a third example, multiply it by 1, 1, 1, we get 2, 2, 2, and the last example will be this one, and here's the result. Now, notice that something interesting happens in 3 out of the 4 cases. Let's look at this one, it's easiest to see. When we multiplied the matrix by the vector, we got a multiple of this vector. We got exactly twice this vector. And just wrote that here. So this one, certainly good. If we look at the first one, then we see that the result is exactly -4 times this vector. Here, this vector is not a multiple of this vector. And here again, we do get a multiple. Exactly 6 times this gives us this. So in some cases, what we get after the multiplication is a multiple, a scalar multiple of the original vector. Okay, I want to spell it out a bit more, add some color, give some labels. Let's call this one vector V. And we see that this times this is exactly -4 times this, because we previously saw it was 4 - 4, 0. And here are the other two examples where we did get a multiple. We found that if we multiply A by this, we get twice what that was, and in the last case we got 6 times the original. Now, when this phenomenon happens, meaning that matrix A times the vector is some scalar times the vector, and we assume the vector is not 0, otherwise it's not interesting, because if vector V is 0, any matrix A times the 0 vector will always give the 0 vector, and 0 is a multiple of itself. It's anything times itself. 7 times 0 is 0, and 100 times 0 is 0. Anyway, it's not an interesting case. So, okay, when this phenomenon happens, then we call V an eigenvector. This is the general V, not specifically this one. I'm just in general. So when we have a matrix times V is some scalar multiple of V, V is called an eigenvector of A, corresponding to the eigenvalue x. Here we could mark x. This would be the x here. This would be the x here. And this would be the x here. Spelling it out yet again. This vector is an eigenvector corresponding to the eigenvalue x equals 4, because A times V is -4V. And we saw that this column vector, call it U, is an eigenvector corresponding to eigenvalue 2, because A times U is 2U.